As we start chapter 2 now, we're going on to 2.1, complex numbers. We want to do these objectives, and again, we'll be going through these as we go. It's always a good idea to get a general idea of what it is. Pause and read them. And we're now going to define what is a complex number. Well, a basic part of a complex number is what we call an imaginary unit. Now, this sort of describes it, but it was the word that was used when they first developed this, the mathematicians. But here's basically what it is. Now, when you take the square root of a 1, it's a 1. The square root of a 4 is 2 times 2, or negative 2 times negative 2. But how about if you go to take the square root of a negative 1? And you might say, well, are there any numbers in real number form that will give you a negative 1 that are the exact same numbers? Well, if you multiply two positives, you get a positive. If you multiply two negatives, you get a positive. So there's no way to multiply two numbers that are exactly the same and get a negative. So scientists were in a quandary as to what to do. So they invented something. They said, let's take out the square root of negative 1. And then that's going to be times the square root of 1. Now, if we multiply this, we get the square root of negative 1. And let's define this, the square root of negative 1, using the letter I. Okay. So there's the imaginary unit that they're calling the letter I. What is that? It's the square root of negative 1. Now, what is I squared? Well, that would be the square root of negative 1 squared. Well, we had said that if you are, and then the root number, the index number here is 2, anything to the square root raised to the second power is just the radicand. So the square root of a negative 1 squared is negative 1. So that's the defining point. I is the square root of negative 1. I squared is equal to negative 1. Keep that in mind. That'll be useful as we go on. Now, when we get this imaginary unit tied into real numbers, we then end up with a form something like this, where A is the real number plus or minus something in this second position is the imaginary number or the imaginary unit. This combination is the complex number. Okay, so what's a complex number and what's its standard form? The standard form of a complex number is this. So again, some good notes, and hopefully you see where it all comes from. Now, in dealing with complex numbers, we think of the I, this I, just as if it were a variable. But an interesting thing happens to it that we'll show you in the future. Okay. So example 1, we're going to perform addition. Well, first of all, we can take our real numbers and just add them together. And we can take our imaginary numbers and add them together. And 5 and 3 is 8. a negative 2i and a positive 3i just gives us a positive 1i. Now remember, anytime there's a symbol with nothing in front, there is an assumed 1 there. Now, for subtracting, we have to remember that when we take away the parenthesis, we have to change each of the terms inside to opposite signs. So this is going to become a negative 12, and this becomes a positive I. So now we add our 2 and negative 12, get a negative 10, a positive 6i, and an I. Remember, there's a 1 in front. Gives us a 7i. And again, this is in complex form. A plus bi. So we always have to write our answers like that. All right, let's go on. Now, in example 2, there are two problems, an A and a B, and it's pretty straightforward, although this is the little interesting part. So we're going to distribute that, and we get 14i. That's straightforward. We distribute this, and we get a negative 7 times 9 is a negative 63. But now I times I gives us I squared. Now, one of the things is you never leave I square as an answer, because we know that I squared is a negative 1. So now we have to multiply this negative 63 by I squared, which is a negative 1, which gives us a positive 63. But notice now, this is not in standard form, A plus BI. So to present the answer correctly, we have to switch them around as is indicated here. Okay, now this is the old FOIL that you may recall from your high school days. And again, FOIL. We're going to multiply the first. In fact, I'm going to do this in, well, they do it by FOIL. Good. All right. First gives us 5 times 6, which is 30. And they're showing it in detail. Now your outers give you a negative 5 times 7 is a negative 35i for the outers. The inners now, 4i times 6 is a positive 24i. And the last now is a little tricky, so you have to be careful. One's positive, one's negative, so you're going to get a negative. 4 times 7 is 28, but now I times I is I squared. Now remember, we can't leave it as I squared. This is going to become a negative 1 that they show down here. So in a sense, this loses its variable. So then we get a 30. We add these two terms and get a negative 11i, and this now becomes a positive 28. So 30 and 28 are like terms. Add them together, get 58, and a negative 11i. This is in standard form, A plus bi of the complex number. One of my favorite words in mathematics is what we're going to see here. That is the conjugate of complex numbers. Well, first of all, what is a conjugate? Well, from standard real number combinations, if we had A plus B and A minus B, you see these are the same terms. One's a positive and one is a negative. Now, when we multiply conjugates, and these are conjugates, where it's the sum and the difference of the same terms. When you multiply conjugates, the inners and the outers cancel out through subtraction, and you get the difference of perfect squares. So we have what is a conjugate of a complex number. Well, let's look at it. So if we had a plus bi, what would the conjugate of that be? Well, it'd be the same terms, a and bi, but here it's the opposite sign. So these are complex conjugates. Okay. Now, when we multiply this, we're not going to end up with middle terms. We could just get this. We get a squared, and then our last is b squared. It should be a minus b squared I squared. Okay. But we know that I squared is going to be a negative 1. So this ends up being then a squared plus b squared. And that's what they're showing us here. Okay, I did it pretty much the same way. Here it's laid out a little bit more. Complex conjugates. Here they're telling us in division, we do not want to leave a complex number in the denominator. So we want to, like in the old days, rationalize the denominator, where we're going to uncomplex the denominator. Let's see an example. In fact, I'll go to the whiteboard for this, so you can do this with me here. So we have 5 plus 4i all over 4 minus I. Go to the whiteboard. So again, we can multiply this by a 1. Wouldn't change its value. But the form of 1 that I'm going to use now will be the conjugate of the denominator. And that would be a complex conjugate. Let's get that going here. So what am I going to put here? Well, again, the same terms, 4 and an I. And to make it a 1, this has to be a 4 and an I. And what's the opposite sign? Well, plus. Now, generally, anything divided by itself except 0 is going to be a 1. So this is a form of 1 here. So now we're going to FOIL the top. And I'll show you the lines. This is a 20. Now my firsts, now my outers. This is a positive 5i. My inners, a positive 16i. And now my last is going to be a plus 4i squared. Now keep in mind this I squared is going to become a negative 1. We'll do that shortly. But let's do our bottom here. 4 times 4 is 16. And then negative I plus a positive I is a negative I squared. So we're going to collect like terms now. Well, a little bit of like terms. So 20, and then this is plus 21i, and this is now 4i squared, but this I squared is a negative 1, so this becomes a negative 4. Now my bottom is a 16 minus, this I squared is a negative 1, so collectively this now becomes a positive. And I now have a negative 4 and a 20, which is a 16 plus 21i, and that's all going to be over 17. And that's what they show you on the slide, but I thought it was nice working it out this way. Now, I haven't finished this yet, because this is not in the a plus bi format. So I have to put the 17 under the 16 and physically separate it into a real number and an imaginary number, collectively making it a complex number. That's the official answer. Here is a definition. The principal, the main square root of a negative number is, for any positive real number b, the principal square root of a negative b is defined by taking the I, which is the square root of a negative 1. Let's just tease this apart. So in a sense, this is the square root of negative 1 times the square root of b. So we said in the first slide or so, we define this as I, the square root of b. Okay. Now notice this is not quite written in standard form. It should be and is equivalent to the square root of b and then I outside of the radical sign. They often write it like this so that the I is not confused as possibly being under the radical sign. Now in example 4, as we look at it, we have these two imaginary numbers. So the first thing you might do is just take out the I and get I, the square root of 27. But we know the square root of 27 can actually be simplified into I, still out there, the square root of 9 times the square root of 3. Now, what they're doing here from this step to this step is they're just submitting this, hoping that you know it already. So the square root of 9 is 3, so 3i, the square root of 3. And the same thing applies here. Take out the I, you get 48, and then 48 is the square root of 16 times the square root of 3, and the square root of 16 is the 4, so you get the 4i, there's an I there, and the square root of 3. You now have what are called let me clear this up, imaginary numbers. So the square root of 3 part is the same, so we just add our imaginary portion, which is 7i, the square root of 3. Okay? Now here we're squaring this binomial, and again, what we have to do in this square root of negative 3 is take the I out. And we can expand it like so, and then FOIL. So negative 2 times negative 2 is 4. Now our outers would be a negative 2 times a negative I, which is a negative times negative gives you a positive 2i, the square root of 3. Your inners, a negative 2 times a negative I, another positive 2i square root of 3. And then the last, this is interesting now, negative I times negative I, that's going to be your I squared. And the square root of 3 times the square root of 3 is the square root of 9. That becomes the 3 there. Okay. So we know this is going to be a negative 1. So this ends up being a negative 3 here. We add these together, they're like terms, gives us a 4i square root of 3. And 4 minus 3 gives us the 1. And we've written it in standard form, a plus bi. Hopefully here we're digging into your background a little bit, and we're talking about the quadratic equations that will end up with a complex imaginary solution. Well, what does that mean? Well, background. What's the name of this equation? Well, this is the standard form of the quadratic equation. that can be factored to find the solutions, or the general form of finding what the value of x is if you solve this equation for x, you get the quadratic formula. Now, within the quadratic formula, what we have under the radical sign, which is the square root sign, that's called the discriminant. And if the discriminant ends up being negative, you're going to have that negative value under the radical sign, and you'll get an imaginary number. So the solutions of this will be complex numbers. Okay, let's go on. Now our last example, example 5, says solve using the quadratic formula. Well, they listed here for us. There's your equation in standard form. We have to identify our A term, which is a 1, our B term, which is a -2, and our C term, which is a 2. We plug it in, do the calculation, and we end up with this. Now, notice that under the radical sign, the discriminant is a negative. So this is going to be, when we simplify that, we take the I out. That would be the negative part. And then square root of 4 is 2. So 2i. Now, in a sense, you could put this 2 over 2 plus or minus 2i over 2 also. Or, as they do it, they're factoring out a 2 from each term, canceling these out. So our answers then are 1 plus I as one answer and 1 minus I as the other answer. And this is in roster notation. Okay, a lot of background for dealing with complex numbers.